Okay, so now we are going to talk about Venn diagrams and set notation. So what you're going to learn here is how to create Venn diagrams, how to find probabilities using Venn diagrams, what it means when events are independent, and what is conditional probability. So here I have a situation going on in Miss Alexander's classroom. There are 12 boys and 16 girls. On Monday, 4 boys and 5 girls were wearing white shirts. I'm going to go ahead and identify my events here. I should have did that when I made it. So we're going to say W is white shirts. I'm going to look at this at the standpoint of boys. So B is boys. These are the two things that I'm comparing here. So I'm going to draw my Venn diagram, and this is called my universal set. Everything goes in this space, and I'm going to have my two circles, and in this course we really deal with just two. When you get in other courses you'll probably deal with more. I'm going to call this the white shirts and this the boys, and it tells me that 9 kids have on shirts, that white shirts, that on Monday. So I'm going to put 5 here for the girls and 4 because boys and white shirts overlap right here. Now it tells me that I have 12 boys. I already have 4 here, so I should have 8 over here for boys. So let me count that 8. 8 plus 2 is 10, plus 2 more is 12. Alright, so I got 8 in that spot, and then I have in all 28 people. So I know of those girls, 5 of them have on white shirts, and so I got 16 girls in all. That means I have 11 girls that are not boys and don't have on white shirts. Okay? So that is my Venn diagram created. Now I'm going to copy this and use this to help me answer the rest of the questions. Okay. Okay, so here's my Venn diagram. Alright, so it says find the probability of students having a white shirt and write that in set notation. So the probability of a white shirt, this is called the set notation, equals I have 28 people in all. So I do what I have in all, and then I go and look here to see how many people have on white shirts. So I have 5 plus 4, 1, 2, 3, 4. So that becomes 9 over 28. So I'm going to graph my calculator, and I'm going to round my decimals to the nearest hundredth. So I'm going to do 9 divided by 28 equals 0.32, or you can write it as 32%. Now it says find the probability of students being a boy and write the questions in set notation. So the probability of being a boy equals how many boys I have in all. I have 12 boys in all out of 28 people. And so we're going to write, this is my set notation, this is my probability, and I'm going to write it as a percentage. 12 divided into 28 equals 43%. Now it says find the probabilities of students being a boy and having a white shirt. Write this as set notation. So I want the probability of being a boy, and that means in intersection having on a white shirt. So you can look at the middle here and do that, but there's a way you can do this. This equals the probability of boy times probability of white shirt. And we already found those probabilities, so we're just going to say 0.32 times 0.43. And when we put that in the calculator, we're going to get 0.14, or 14%. Okay? Now it says find the probability of students not being a boy or having a white shirt, and write the question in set notation. So we're going to say the probability of not, which means complement, not being a boy, and so we want the intersection of and having on a white shirt. Okay, so the math behind this would be the probability of not a boy times the probability of, that said or. I'm doing this. Okay, so let me fix that. That says or, not and. So I need to go back and rewrite this. So or means that we need to do the union of all of these. Okay, so it means union of this. So we need to go find what's the probability of not being a boy. Well, I got 11 and 5, that's 16. So 16 out of 28 people, that's the probability of not being a boy, plus the probability of having on a white shirt. So the probability of having on a white shirt is 9 over 28. And if you notice, I am not going to subtract out anything in this problem because not being a boy and white shirts do not overlap each other. So I'm not going to subtract anything out on this problem. Not being a boy, which is the girls down here, and having on a white shirt, those two do not overlap with each other. So I'm not going to do any subtraction for this problem. So here I'm going to say this should be 28 over 25. Yep. And then I'm going to grab my calculator and go 25 divided by 28 should equal 89%. So you get 0.89 or 89% of the students. Okay. All right. So that's that page. I'm going to go and go to the next page. Now let me paste this in. Move this on over. Alright, so let's finish answering the rest of the questions. It says find the probability of students having a white shirt or being a boy and write the question in set notation. So now I get the probability of a white shirt or, so the union of being a boy. So what this tells me to do is to do the probability of the white shirt plus the probability of being a boy. But if you look, there's a spot where white shirts and boys overlap. So we're going to say minus the probability of a white shirt and being a boy. So let's get the probability of a white shirt, which we already know from the previous page. Probability of a white shirt is 0.32. So I'm going to put 0.32 plus probability of being a boy. I'm going to grab that from the other page, or you can just recalculate it. 0.43 minus the probability of being a boy and having a white shirt. Or you can do 4 over the total amount, which is 26. Or you can go look at your other problem where you already calculated this, which is going to be 0.14. So we're going to subtract out 0.14. And so the answer to this question would be 0.32 plus 0.43 minus 0.14, and this equals 0.61%. Or you can put 61%. Alright, so 61% of the students have a white shirt on or is a boy. Now the next one says find the probability of students being a boy given that they have a white shirt. Write this as set notation. So I'm going to write exactly what I see. The probability of the student being a boy, and this is called given, this is conditional probability, they have a white shirt. So conditional probability, there you go. So there's a boy given that they have on a white shirt. So the way you break up this probability, your formula sheet does it as event A, event B, that equals the probability of event A and B over the probability of the second event. All right, that's what that formula is. Or if it's written this way, leave it alone. Okay, so that's the formula on your formula sheet. So you can always replace B and W, are the letters you have, with B and A. Just know this is the first one, this is the second one. So here I have the probability of boy and white shirt over the probability of a white shirt. So we already know the probability of boy and white shirt to be 0.61, and the probability of white we already calculated is 0.32. So we're going to take this and divide them. Oh, we are wrong, because the probability cannot be greater than 1. So let's go and look and see where I'm wrong at. So it says the probability of okay, let me redo. So let me break it down. It says the probability of having a white shirt, so the probability of being a boy and having a white shirt over the probability of a white shirt. So this should equal, being a boy and the probability of a white shirt should be 4 over 28. Divide that by the probability of having on just a white shirt, so it should be 9 over 28. Probability of having a white shirt on, yes. And then the probability of being a boy and having a white shirt. Okay, so I'm going to go here. I don't know what I did wrong with that other problem, but oh, I was using the wrong one. That was for or, not and. Okay, my bad. That was or. So here we should have took the percentage for the and problem. Let me go back and show you that. I was messing up because I took the percentage for the or problem. I should have took the percentage for this problem, 0.14. And you're going to notice what's going to happen here. I'm going to go ahead and put 4 divided into 28 into my calculator, and I get 0.14. So I get 0.14 divided by, then I go and do 9 divided into 28, and I get 0.32. So I had the wrong one at the top, and that equals 0.14 divided by 0.32 equals 44%. So 40.44, or the answer to this question is 44%. So 44% of the students will be a boy, given that they have a white shirt on first. Okay, so now it says find the probability of students having a white shirt given that they are boys, and write the question in set notation. So the probability of a student having on a white shirt given that they are boys. Okay, so this time it should be set up as the probability of white shirt and being a boy over the probability of being a boy. So the probability of the first one and the second one over the probability of the second one. That's this formula. That's what this formula means. So here we already know the probability of being having on a white shirt and being a boy is 0.14 divided by the probability of being a boy. That one we already have on the other page. Let me go back and look. Probability of being a boy is 0.43. So I'm going to come over here, divide this by 0.43. And if you needed to figure that out, then you go here. The probability of being a boy is going to be 12 over the total amount of students, which is going to be 12 over 28, which is 0.43. So now I'm going to take the calculator and do 0.14 divided by 0.43 equals 33%, equals 0.33 or 33%. And then you finish with those problems. Okay, so you will need to go through and do this one, answer your questions, make sure you read carefully, answer these questions, draw your Venn diagrams, make this go, and I will see you guys on tomorrow. Bye.